This is one in a series of videos that explain how to use the program Comprehensive Meta-Analysis. We have several series of videos. One works with means, one works with proportions, and this one works with correlations. Within each series there are videos that show you how to enter data, how to run a basic analysis, and so on. This particular video is the first in the series, and it tells you how to enter data into the program. When you open the program offers you the option of working with a tutorial. I'm going to close that, and I'm going to say Insert column for study names, and the program creates a column called study names. Then I'm going to say Insert column for effect size data. One of the nice things about this program is that it allows you to work with data in more than 100 different formats. So we need to tell the program what format we want to use. I'm going to click Next over here. The program presents 4 general options. I'm going to select the first of these, click Next, and we have over here options for working with dichotomous data, continuous data, correlations. I'm going to check that one, and under that we have computed effect sizes. And then we see there are about 8 or 10 different formats. I'm going to select the first one, which is simply the correlation and sample size. I click Finish, and you can see over here the program has created columns that allow me to enter the correlation, the sample size, and the effect direction. I'll speak about that in a minute. So the first study that we have is a study called Fonda, and the correlation was 0.5, and the sample size is 40, and the effect direction is automatic. I'll come back to that in a minute. The next study is Newman. The correlation is 0.6, the sample size is 50, and the effect size is automatic. And you can see that immediately the program has computed, well, it's reflected back the correlation, and it also has computed the standard error and the variance. Something that we'll be talking about in the next video is the fact that when we are working with correlational data, the program does not actually use the correlations themselves to perform the meta-analysis. Rather, it converts them into something called a Fisher z-score. That is not the same as a regular z-score. It's something called a Fisher z-score, and it performs the analysis on these scores, then converts them back to correlations. So for those of you who want to be able to follow the computations, this is the Fisher z-score, and the variance for Fisher z and the standard error for Fisher z corresponding to the correlations that you see over here. One thing that you can do is you can double click on any of the numbers over here, and the program will show you exactly how it computed that number. So for example, over here is the formula for computing Fisher z, the formula for computing the standard error, and so on. You will notice that the program not only computes these numbers, but actually takes the values that we've put over here and plugs them into the formulas. So for example, if we want to see the formula for getting the standard error of the correlation, the program was working with 0.5, which is the correlation over here, and the sample size, and plugs all those numbers in and gets a standard error of 0.123, which is the number that we see over here. Something else that might be helpful is if you double click on any of these numbers over here, the program pops up with a sort of a table where you can enter the correlation, the sample size, and the effect direction, and using sort of a tabular format rather than the spreadsheet. Over here I mentioned we have this column called effect direction, and normally we're going to use auto. What that means is simply that if the correlation over here was positive, like 0.5, then the correlation shown over here is also going to be positive. And if the correlation over here was negative, then the one over here is also going to be negative. In almost all cases, that is going to be the option that you want to use. However, there will occasionally be a situation where you want to reverse the direction of a correlation. Let's say, for the sake of argument, that you're looking at a number of studies, and most of them are looking at the correlation between 2 scales, and both scales are going in the same direction, so that you're going to expect the correlation to be positive, and that's what's going to happen. But then you have one study which looked at a scale which is going in one direction, and the correlation between that and a scale which is going in the other direction. So for example, all of the studies looked at correlation between self-esteem and the score that you got on a test, but then suddenly there's one study that looks at the correlation between self-esteem and the number of errors that you made on the test. So what we would expect is that if all the other correlations are positive, this correlation would be negative, but in a sense that's only because of the way the scale was scored. What we really want is for this correlation to be moving in the same direction as the others. So what you can do over here is, rather than selecting auto, you can choose negative or positive. And if you do that, the program will take, for positive, it will put a positive sign in front of the correlation. For negative, it will put a negative sign in front of the correlation. Just to be absolutely clear, the intent over here is not to use this to reverse the results of a study that actually showed an effect in the opposite direction. Rather, the intent is, if this study is showing the same results as the other studies, but it simply happened to use a scale which was scored in reverse, you want to be able to correct that in a simple way, and that is what this allows. At this point, I want to enter information for a few more studies. Rather than typing in that information directly, I'm going to come to an Excel spreadsheet where I had saved that information earlier. I have over here Grant, Granger, Milland, and Finch. I'm going to highlight the correlation and the sample size. You will notice, of course, that I have the information in the same format that I had it in the in CMA. Control C to copy it. CMA, click over here, Control V to paste it. And now I have that information pasted into the program. The only additional thing I need to do is to add auto for each of these. And now I have my data set. I'm going to save that. I'm going to give it a name of correlation data entry, and save it. There are a couple of other things I'd like to show you quickly before proceeding. One thing is that you can right click over here on any of the yellow columns, click Customize Computed Effect Size Display, and let's say, for the sake of argument, that I'm not interested in seeing Fisher Z. I can click on that, get rid of it, so I'm looking only at the correlation. Also over here I have the option of showing the standard error and or the variance. So if I wanted to see only the standard error, I could do that. If I wanted to put the variance back in, I can do that. Something else we need to deal with sometimes is a situation where some studies gave us the correlation and the sample size, but other studies gave us a different set of information. I'm going to come back over here, say Insert Column for Effect Size Data. Let's say that a study gave us the p-value and the sample size. Let's call that study Rothstein. You'll notice over here there's a column called Data Format. I do not enter data over there. The program will fill that out for me automatically. Let's say that the p-value is 0.04. This was a two-tailed p-value. You'll notice, by the way, that the program has now filled this in by saying that we're entering the p-value for a correlation. The sample size was 100. The effect direction, in this case we cannot say auto because the program doesn't have any way of knowing if it's a positive or a negative correlation, so I'm going to say positive, and the program based on that has computed has back computed the correlation as well as the standard error and the variance. You'll notice that down here now there's a tab marked correlation, there's a tab marked p-value for correlation. If I now want to enter data for an 8th study that provided data in the same format as the first 6, I can click over here and get back to this format. If I wanted to go ahead and see this data over here, I can simply click on that study and the program will simply make those columns visible again. As a matter of fact, I can right click over here, say Show All Data Entry Formats, and you can see that what the program is doing is very similar to what you can do in Excel by simply hiding sets of columns and then unhiding them. Generally, it's easier to click Show Only the Current Data Entry Format. It makes the screen a little bit easier to work with. At this point, we have 7 studies. The first 6 of them had this kind of data, the 7th had this kind of data. If I go ahead to run the analysis, the program is going to take all 7 studies and include them in the analysis. It does not matter that some of them provided data in one format and some provided data in a different format. The only thing that matters is that they all were able to yield a correlation and a Fisher Z-score. It is the yellow columns that are being sent over to the analysis module. not the white ones. It doesn't matter what kind of format was initially used to enter the data. The only thing that matters is that we have the correlation and its variance. This is a fairly simple set of data. The program is also able to handle more complex types of data. That would be, for example, when you have some studies that provide a correlation for 2 or more independent subgroups. For example, the program might give you the correlation between self-esteem and score on a test, and it might do that separately for males and for females. In that case, you would need 2 rows for each study, 1 labeled males and 1 labeled females, and the program is able to deal with that. You also might have studies that give you correlations or other kinds of effect sizes for 2 or more outcomes. For example, you might have the correlation between self-esteem and score on a reading test or score on a math test. And so you need a way to enter both kinds of outcomes for each study. You might have the correlation between 2 scores immediately following an intervention, and then again a month or 2 months later. There's a way to do that. And so we're going to address all of that in another video called Working with Complex Data Sets. Let me point out that the data set that I used over here is available in our book, Introduction to Meta-Analysis. These data sets are also available online. This is the data set that I used. This is in chapter 14. And the book and these PDFs also show you how we took these numbers, converted them into z-scores, went ahead and computed the fixed effect and random effect analysis, created graphs, and so on. Finally, earlier in the book, there's this section on computing effect sizes where the steps for computing the effect size and the variance are explained in more detail. And in the book, we use the same data set that we're using in this video to make this somewhat easier. Finally, there is an Excel spreadsheet available online which has the same computations that we're looking at over here, and then proceeds into actually performing a fixed effect and a random effects meta-analysis, as well as more advanced analyses. And you can access that online as well and follow along with all of the computations. The next video in this series is the one that shows you how to go ahead and perform a basic meta-analysis. I hope that you will join me for that one. As I said before, there are parallel videos working with means and with proportions, so please feel free to have a look at those as well. Thank you.